Hey everybody, welcome to week 3 of physics. Today we're going to be talking about potential energy and kinetic energy. These two things together make up mechanical energy. When you see things like EP, that represents potential energy or energy potential. If you see it written as EK with a little k, that is referring to kinetic energy. All right, we're going to start with potential energy, get to kinetic energy after. But a few things to recognize and to know here are, you'll see, are this. Okay, so work and energy are actually one and the same. So basically, what work is saying is the force of impact, right? So potential energy, what potential energy is essentially is, if we're talking about this pen here, you take its mass, its gravity, and its height, and it's saying how much energy is stored within that object if I were to let it go and drop and hit the ground. So what work measures is the force at impact on the ground, so how much force it hits the ground with. What energy, potential energy calculates is how much energy is stored in this object if it simply falls to the ground. And obviously it's not taken into effect wind or anything like that. It's just the simple equation of this object falling with the force of gravity to the ground. Okay, so work and force are one and the same, or they are equal to each other. Okay, so how is work is done to an object when energy is changed? So anytime you're writing energy, the unit they use is a joule. Okay, you've probably heard the term before, but never really knew what it is. But basically, a joule is a unit of energy. So that's what we're going to be writing. Okay, for this, and the equations for them, okay, are written here. Okay, so the formula for potential energy is right here. Okay, it's EP equals mgh. So what that is mass times gravity times height. And gravity on Earth is always 9.81 meters per second squared. Okay, if you look at the top of page, let me double check, 41 in your note packet, there is ways to rearrange this. Okay, so you're going to get questions even right following this. How do you, if you're given potential energy of an object, can you solve for mass? Can you solve for gravity on a different planet or somewhere else, or height? Okay, so if you look at the top of page 41, it has that those written out for you. For example, mass equals potential energy over gravity times height. Height equals potential energy over mass times gravity. Okay, so you can rearrange the formula in order to answer your questions. Okay, so really you can solve for any of these 4 variables here, as long as you have the other 3 pieces of information. Okay, and remember, if you're reading questions, which will happen quite often, it's not going to state the gravity of Earth. Okay, it's not going to say 9.81, so you might only have 2 numbers in there, and you just need to assume that is 9.81 because you are on Earth, and that is gravitational force of Earth. So if you only have mass and height, and you're like, we don't have enough information to answer the question, remember you always have this, okay, unless you're in outer space or something like that, okay? So another thing to recognize is the units that these are written in, okay? When you're doing this calculation, mass must always be written in kilograms. So if you are given something in grams, you must convert it to kilograms. Okay, gravitational acceleration is always meters per second squared. And I don't think you'll ever have to convert that, but you need to know in case you do. And height is always in meters. If it gives it to you in feet or miles or kilometers or centimeters, must be converted to meters. Okay, you must use those to get an accurate potential energy. So no matter what the units are written in, always convert them. The examples we're about to do, they're in the proper unit, but you need to recognize that, okay? So here's the example that we're going to cover. Marvin the Martian has a mass of 34.0 kilograms and is 67 meters above the surface of Mars. If he has 7,449 joules of potential energy, what is the gravitational acceleration of Mars? So this is another example, or this is an example of one that you would have to rearrange the original formula. So potential energy, or EP, equals mass times gravity times height. What do we not have in this? Gravity. So we need to put gravity on the other side of the equation, okay? And gravity is going to equal EP over mass and height, okay? So I'm just going to go through and write that. I'm going to pause the video so you don't have to watch me writing it because I struggle with the pencil, and then I'll continue. Okay, so to simplify these questions, it's very important that you do this in steps and segments, and it keeps it a little bit more organized. Excuse me. Otherwise, it gets really, really messy and sloppy. So it's important that you do these big complex equations like this, okay? So the first thing you do is right here. Oh, did not mean to do that. The first thing you do here is write down what you know. So I wrote down these 4 things on the side. It's a different color here. Wrote down these 4 things on the side. So I know what potential energy is. I know what mass is. I know what its height is. And I don't know what gravity is. Okay, so that's why I put a question mark here. I verified that the units are correct, which they all are for this equation. They won't always be. And so this is my know. This is what I know. Then I wrote down the formula for potential energy. It's not that neat, but potential energy equals mass times gravity times height. And then down below, I wrote the rearranging. I'm just going to get rid of this box here. There you go. Then I wrote the rearrangement. So gravity equals EP. Oh, and it looks like that is not staying. EP over mass times height. Okay, that should be an H. There we go. Okay, so then you just factor in your numbers after you're done that. Okay, so factor in your numbers. I don't know why everything just erased. That is so weird. So I'm just going to put my numbers in. So gravity equals EP, which is 7, 4, 4, 9, over mass of 34 times 67. So plug that into your calculators and you will get the proper answer, okay? So after punching that into my calculator, I get an answer of 3.26. And that's going to be meters per second squared. So you can tell that it has much lower gravity on Mars than here on Earth. Okay, so that's the gravitational acceleration that we just solved right here. All right, so that's potential. Okay, so another practice question here. So this is asking if 480 joules of work is done to lift an object 1.5 kilogram that weighs 1.5 kilograms straight up, how high has it been lifted? Okay, so remember, it's saying this is how much work is done. Remember, work is equal to potential energy, like I said at the start of this video. So I'm going to write down the things that I know. So I know the mass, I know the potential energy. This is joules, this is meters per second squared. This pencil does not recognize very good, so I'm sorry. This is gravity, and what we don't know is height. It's asking you how high has it been lifted. So again, I need to rearrange this question. So the original formula is EP equals mgh. Okay. To rearrange that for height, it's going to be height equals EP over mass times gravity. And then I just plug in my numbers. Okay, keep it organized. So height equals potential energy of 480 over 9.81. Sorry, this is out of order. Times 1.5. I'm just going to pause the video, type that into my calculator. So I type it into my calculator and I get an answer of, oh, you can't see my phone, 32.06. And the next slide, it says the answer here, 32.6 meters. So I'm correct. Okay, so that's going to leave you up to page 42 in your note packet. So it's going to let you practice, do a whole bunch of practice questions. Like I always remind you, I'm sorry if this is getting repetitive. You do not need to do all the practice questions. Just do what you need to do, okay? So give those a try and reach out to me if you are having a hard time. There again is how to rearrange the formulas. And if you're looking for gravity, which is very rare, but we did it earlier, remember it's gravity equals EP over whatever the other two are. Okay, so mass and height. Okay, and that is potential energy. That is it for this video. Good luck, guys.